rock types that we will be discussing in this module, sedimentary rocks are the most common. And I understand if you would be thinking like, oh, sedimentary rocks are boring, they're very common, they just form wherever, and they form very easily. And that's true, they're common and they form quite easily, but for me, sedimentary rocks tell the most story. Igneous and metamorphic rocks are formed in their own unique ways, but sedimentary rocks, they have to form from their environment. So sediments from their environment compose this rock type. And the good thing about this is it records what is happening in that environment during its formation. So one example of a sedimentary rock, I think, that gives a story is this. I'm actually not sure what this is. I think it's a shirt. But the cool thing about this sedimentary rock is it contains a fossil of a coral. There. So that's the only unique property of sedimentary rocks. It contains organic materials or fossils. You won't find fossils in metamorphic rocks or in igneous rocks because they undergo too much heat and pressure during their formation. But sedimentary rocks, they are able to hide and keep these fossils that geologists and archaeologists look for in order to study our past. So they're still pretty cool for me. Okay, so speaking of cool, this is another awesome place that I would like to visit one day. This is the White Cliffs of Dover in Kent, England. So as you can see, their unique characteristic is, as the name suggests, is it creates this white cliffs. And all of the white cliffs is a large chunk of sedimentary rock. But what's so special about it? Why is it color white? Well, that's because this area here, this cliffside here, used to be underwater. The water levels of the previous Earth is higher since the temperature was higher. And what happened is the bodies of organisms which have shells have deposited in the ocean floor. Then after hundreds of years of shells being deposited in the ocean floor, it created this layer of cliffs. So lots and lots of shells have been deposited, millions of shells have been deposited just to create the White Cliffs of Dover. So quite exciting if you think about it. How the Earth has already changed after so many years, and it will continue changing. Okay, so sedimentary rocks are rocks which form due to weathering and erosion. So since weathering and erosion are constant in our Earth's surface due to climatic events, organisms, and other tectonic processes, then you create new rocks then. So the old rocks are broken down and thus creating your sedimentary rocks. So due to the process of weathering, erosion, transport, and deposition, the sediments are then formed into new rocks. Okay, so there is a continuum or a process of how sedimentary rocks are formed. So first, it undergoes the former rock, so pre-existing rock, either sedimentary, metamorphic, or igneous, must undergo weathering. So either it will be exposed to physical or chemical processes. Then eventually, since the rock has now broken down, the materials in the rock will now erode, so eating away from the source itself, so dropping from the rock itself. Then after that, it will be transported either through air, by wind, water, or due to other organisms, they will be transported into another location. After being transported, they stop, and that's called a deposition. So they form somewhere or they aggregate somewhere before being lithified. So lithified means being formed into a new rock. And that formation in sedimentary rocks is called diagenesis. So they undergo either compaction and cementation. So it's always together when it comes to compaction, cementation. So when we say compaction, they are pushed together, and cementation occurs when there is water present. So the minerals within the rocks is dissolved into the water, and then eventually, due to evaporation, the water eventually evaporates, but the minerals that has been left behind creates this cementation process. Okay, it could also go through a recrystallization due to the calcium carbonate that is present in the material, or it could also undergo bioturbation. So bioturbation is any process wherein rocks are formed due to the organisms or the plants that surround it. So animals and plants could contribute in the formation of sedimentary rocks. So for example, chicken and birds. The birds in general, they have a very bad digestive system. So sometimes they eat small pebbles or small particles of sand, so it will help with their digestion. So eventually they will poop that out because they don't need that in their system for a long time. So, and then the poop will create this new sedimentary rock. So that's an example of bioturbation. Okay, so this is showing you the Golditch stability series. So it shows you the different types of minerals and how they react to weathering processes. So it will show you here that quartz are stable due to the presence of covalent bonds in the mineral itself. So you don't find much quartz in sedimentary rocks. In the opposite side, you have your olivines and pyroxenes, which has cations and ionic bonds. They are least stable, thus are more present in sedimentary rocks. Okay. Now, when we are classifying sedimentary rocks, there are also two types. So first is your detrital or clastic sedimentary rocks. So these are formed due to physical processes. So that's something that you should remember. Clastic forms from sediments due to physical processes. So they are formed from sediments, rock minerals, okay? They contain quartz and clay minerals. Then for non-clastic sedimentary rocks, these are due to chemical processes. So this one physical, this one chemical. These are formed due to evaporates and precipitates. So whenever we look at water, it's not just pure water. There will always be dissolved minerals and other precipitates in that water. Now, eventually, once the water evaporates, it will leave behind whatever mineral is within that water. And that's one way to form your non-clastic sedimentary rocks. Okay, so due to that nature of water evaporating, and then what it left behind creates your sedimentary rock. Sometimes it also involves biological matter. Okay, so this is showing you the different types, or the different types of clastic sedimentary rocks. Because when it comes to sedimentary rocks, we can classify them based on the grain size. So we have the same idea when it comes to igneous rocks. We classify them based on coarse-grained and fine-grained. So same goes with classic sedimentary rocks. Gravel or conglomerates, which is a type of classic sedimentary rock, usually have particles which are more than 2 millimeters in diameter. So gravel, sometimes after compaction and compression, they aggregate into this conglomerate. So as you can see in this picture, the pebbles or the gravel itself is very visible in that new rock. Okay, then you have your sandstone. So sandstone, it's composed of smaller particles than conglomerate, but still visible to the naked eye. So eventually, the sand will also compress and create your sandstone. So not as coarse as the conglomerate, but still visible to the naked eye. Next, you have your silty mud, which has a smaller particle size and thus eventually creating your siltstone. Okay, so this is a special type because it creates layers like of shale, for example. Okay, so shale is a type of sedimentary rocks which creates this layering process. Okay, so they have layers because it's made up of silty mud. So imagine mud, then it compacts itself and then forms a new rock. Then more mud is formed on top. Then it solidifies and creates a new layer, so on and so forth. So now you have this layer of shale rocks, and then you have also your clayey mud. Okay, so it's the finest of all the sedimentary rocks because of the particles within the clay is very microscopic. So they create this fine looking rocks, so fine grained rocks. For example, shale, and it also contains organic matter most of the time. Okay, so this is just a short description of these rock types that we have discussed under clastic sedimentary rocks. So conglomerate and breccia are the ones with large chunks of rocks within them, or large chunks of particles. So when you say conglomerate, they contain the rounded particles, while for breccia, it's more of angular particles. Then sandstone has the smaller particles in comparison to your conglomerate and breccia. Okay, so it's showing you different types of clastic sedimentary rocks based on the size of the clast or the particles. So that's the technical term for the particles, the clast. So you have your sand, so creating your sandstone, okay, and then silt and clay create the finer type of clastic rocks. So you can see this, you can imagine that this formation used to be mud, but eventually the water evaporated and this created this cracks, like a cracked layer of dry mud. It's still soft. Often it's still soft, but eventually through time it could further solidify and become just rock. Okay, so angular, Clast shape, meaning it's breccia, rounded, so that means it's conglomerate, could form a conglomerate type of clastic rock, or it could be like a 50-50 in between partially rounded Clast shapes. Okay, so you could also categorize our clasts based on their sorted or how they are sorted. Okay, so this image is just showing you the different ways of how clasts or sediments can travel from one location to another. Remember, the formation of sedimentary rocks, the classic sedimentary rocks, have a series of processes. So after weathering and erosion, it will now transport. So the transformation process could either be because of gravity. So the steepness of the slope will trigger the clasts or particles to move downwards down the slope. Okay, so the steepness of the slope could also trigger the further breakage of rocks, thus resulting to poorly sorted and angular clast sizes. Then you have also the influence of water currents in the sizes of your class. So strong currents can bring large rocks, so you will have large class size. And then for weak water, weak rivers, for example, or weak water currents, you will have fine grained types of rocks because they could only bring small particles. Other agents of transportation, aside from mentioned, you have your ice and wind. So wind, since it could only bring so much, it only brings fine class sizes, so it leads to the formation of fine-grained sedimentary rocks. And then glaciers, however, are, since they're so big, they could bring large and small class sizes. Okay, so other images of our sedimentary rocks, clastic sedimentary rocks. You have your conglomerate as characterized by your large class size, which are rounded. You have your breccia, which are large class size with angles. You have your sandstone, which have relatively smaller class size but still visible to the naked eye. And then you have your shale, which was formed by the layering of fine-grained, fine class size or small class size. Okay. This is an image of your Capsha Cave, in Capsas, Greece. So you will see here that there is a formation of stalactites. So stalactites is this on top, and stalagmites are the one on the bottom. So ever wondered how these structures form? So you may already know that these formations form, or these structures form, because of water. And as I have mentioned before, when it comes to water, they sometimes contain minerals. So since water is moving deep underground, they bring minerals wherever they go. And sometimes this water deposit in caves. Naturally, since the water will eventually evaporate, the minerals which they have transported from underground will now deposit into the caves, creating these structures. So mostly, as you can see, it's white information because there is a large amount of calcium carbonate that has been dissolved in the rock and thus depositing in this cave. Okay, so chemical sedimentary rocks, mostly carbonate based. A good example is limestone. Then silica-based type of sedimentary rocks are also present because they could dissolve in water. Other types of sedimentary rocks or chemical sedimentary rocks are coal. So coal is a special type of sedimentary rocks because it's a combination of fossils. So I mean the coal that we harvest for, not charcoal, that's different. So coal which we harvest for energy. So coal is a type of fossil which we harvest now because coal is a type of fossil from plants, carboniferous plants, way back in our history. So now they have been formed or lithified into a sedimentary rock. So that's what we harvest. And then you have your halite or the rock salt. So as you may know, salt formed due to the precipitate in the seawater. So that is a type of chemical sedimentary rock. So a picture of your rock salt or halite, gypsum, chalk, which is calcium, mostly calcium carbonate, and chert, which is rich in quartz. That's why I actually mentioned that this might be chert because it might be silica based because of its color. And there's also like a transparent, I'm not sure if you can see it. It's like a translucent type of rock. So I'm quite sure that this has silica or other light colored minerals inside. So, That's how I figured it out. So either a combination of calcium carbonate and also silica in the rock itself. Okay, so limestone, you have your siltstone, chert, and then gypsum. Could be gypsum. Could be. I have to have it checked. Okay, so that's all we will be covering for our sedimentary rocks.